If you want to make joints in Tinkercad, you're in the right place. In this video, I'm going to show you how to create moving joints that actually work, using simple shapes, small clearances, and Tinkercad's built-in connector tools. This is perfect if you're designing poseable figures, hinges, robotic arms, lids, or any model that needs moving parts. And if this tutorial helps you out, make sure to hit like and subscribe for more easy Tinkercad tutorials. Alright, let's jump in. The first thing to understand is that moving joints in Tinkercad are all about spacing. If two parts are modeled too tightly, they will fuse together during printing. So the goal is to create two interlocking pieces with a tiny gap, also called clearance, so they can move freely after printing. Let's start with the most common type of joint, the ball and socket joint. This is great for poseable models and any design where you want movement in multiple directions. To make the ball part, drag a sphere onto your workplane. This sphere will be the moving ball inside the joint. Keep it at the size you want for your design, because this will determine how strong and flexible the joint feels. Now for the socket. Duplicate the sphere, then make the duplicate slightly larger. For example, if your ball is 10 millimeters wide, increase the socket sphere to around 11 millimeters. After that, switch the larger sphere into a hole. This hole sphere is going to carve out the inside of the socket so the ball can fit inside. Next, place a box or cylinder around that hole sphere. This outer shape becomes the housing for your socket. Make sure the whole sphere is positioned inside the solid shape where you want the cavity to be. Once everything is lined up, select the outer shape and the whole sphere together, then group them. That creates a hollow cavity inside the housing. After that, place your original ball sphere into the cavity. If the clearance is correct, the ball should set inside the socket without fusing to it. That small gap is what gives the joint movement after printing. If the fit is too tight, increase the socket size just a little more. If it feels too loose, reduce the gap slightly. It usually takes a quick test print to find the perfect balance for your printer. Now let's move on to the hinge joint, also called a pin joint. This is the best choice for things like doors, lids, robot arms, and folding parts. The hinge uses interlocking loops with a pin running through the center. It only allows movement in one direction, which makes it strong and predictable. To build the outer loops, create two cylinders and turn the center of each one into a hole so they look like washers or rings. Attach these rings to your first object, leaving space between them. Then create one solid cylinder for the inner loop and attach it to your second object so it fits between the two outer loops. Now add the pin. Place a solid cylinder through the center of all three loops. This pin acts like the axle that holds the hinge together. The most important part here is clearance. The pin needs to be slightly smaller than the holes in the loops, usually by about 0.3 to 0.5 millimeters, so the parts can move instead of fusing together. If you make the pin too large, the hinge won't turn. If you make it too small, the joint may feel loose. So again, a small test print can help you fine-tune the design. Another great option in Tinkercad is using the built-in connector shapes. This is one of the easiest ways to make joints, especially if you don't want to build everything from scratch. On the right side of the screen, go to the Shapes panel and open the drop-down menu, then select Connectors. Inside the Connectors library, you'll find pre-made joints like ball sockets, rotation joints, and pivot joints. These are designed to fit together properly and save you a lot of time. All you have to do is drag the joint you want onto your model, position it where you need it, and group it with your design if required. These connector shapes are especially useful when you're prototyping and want something that works quickly without manually calculating every dimension. As you work, remember a few practical tips. Always think about your printer's tolerances, because different printers and materials behave differently. PLA, PTG, and resin can all need slightly different clearances. If your printer tends to print a little oversized, you may need a larger gap. If it prints very precisely, you can tighten the fit a little more. Also, make sure your joint has enough wall thickness around it so it doesn't break when moving. If you're making more complex models, it can help to label parts or duplicate them before grouping, just in case you want to make edits later. And if you're experimenting, start with a simple test joint first. That way you can confirm the fit before building the full model. A small calibration piece can save you a lot of time and material. So to recap, there are 3 easy ways to make joints in Tinkercad. You can create a ball and socket joint for multi-direction movement, a hinge joint for one-direction rotation, or use Tinkercad's connector shapes for a faster built-in solution. All of them depend on one key idea, leaving a tiny clearance so the parts can move after printing. If this video helped you, please give it a like, subscribe for more Tinkercad tutorials, and let me know in the comments what you want to learn next. Thanks for watching, and I'll see you in the next one.